Module 9, Acid-Base Chemistry. Molarity. You may have noticed that much of acid-base chemistry involves water. Well, it's time to learn about another concept relating to acids, bases, and all other chemistry that involves water. Toilet bowl cleaners often have hydrochloric acid as their active ingredient in order to remove lime stains from a toilet bowl. Yet there are other products, such as muriatic acid, that have hydrochloric acid as their active ingredient too, but they are able to remove lime stains that regular toilet bowl cleaners cannot. Why is that? Both contain hydrochloric acid, so why is one more powerful than the other? Well, muriatic acid has more hydrochloric acid in it than the toilet bowl cleaner. Muriatic acid contains about 30% hydrochloric acid and 70% water. The toilet bowl cleaner has only 3% hydrochloric acid and 97% water. So, though they both have the same active ingredient, muriatic acid cleans better because it is more concentrated. We need to consider the concentration of a chemical as well as the type of chemical when we're looking at its chemistry. There are several ways to express concentration. I already mentioned one way, using percentage. The higher the percentage of a compound, the more concentrated it is. Concentration is most often expressed in an amount divided by volume. So, grams per milliliter would be a good example. It lets us know how many grams of a substance are in a single milliliter of volume. In chemistry, the most common way to express concentration is using the unit moles per liter. This unit is also referred to as molarity. Molarity, or capital M, is a concentration unit that tells us how many moles of a substance are in a liter of solution. It is determined by dividing the number of moles of a substance by the number of liters of solution. This can be expressed by the equation you see here. M equals number of moles divided by number of liters. Because number of moles is the easiest way for chemists to show quantity of substances, you can see why this is a more popular unit. This way, molarity can be more easily used in stoichiometry problems. Let's look at exactly how molarity can be used. Muriatic acid is most often sold in a 4-liter bottle. In that 4-liter bottle, there will be 1,400 grams of hydrochloric acid, and the rest of the container is filled with water. If we look up the molecular mass of hydrochloric acid, we can calculate it to be 36.5 atomic mass units. That means that it takes 36.5 grams of hydrochloric acid to make 1 mole of hydrochloric acid. Well, we can now set up a conversion problem using our conversion relationship. We have 1,400 grams of hydrochloric acid and can multiply it by the relationship so that grams of hydrochloric acid cancel. Thus, there are 38 moles of hydrochloric acid in that 4-liter container. Well, once we know how many moles we have, we can figure out the concentration of the acid by using molarity. We just need to divide the number of moles by our volume. So 38 moles divided by 4.00 liters gives us 9.5 molar. Well, what does that mean? We aren't just doing this for math practice. The concentration of an acid, or a base for that matter, tells us how strong it is. Stronger acids will react more powerfully than weaker ones. For example, a specific brand of toilet bowl cleaner is about 0.8 molar. We just calculated muriatic acid to be 9.5 molar, so it is more than 10 times as strong as toilet bowl cleaner. That means that it will definitely do a better job of dissolving the lime on porcelain, but you need to be more careful not to get any of that liquid on your hands. Let's look at another example of calculating molarity. What is the concentration in units of molarity of sodium hydroxide, or NaOH, if there are 2.6 moles of the substance in a solution with a volume of 534 milliliters? To determine molarity, we need to have the number of moles of sodium hydroxide and divide that by the volume of the liquid in liters. Well, we have the number of moles already. We just need to convert that volume to liters. Our conversion relationship is 0.001 liters equals 1 milliliter. Note that you could also use the conversion relationship of 1,000 milliliters equals 1 liter. The answer will be the same. Taking our given amount and multiplying through, we get 0.534 liters. To calculate molarity, all we need to do is set up our division problem, 2.6 moles of sodium hydroxide divided by 0.534 liters, and we get 4.9 moles of sodium hydroxide over liters, or 4.9 molar concentration. Here's another one. Give the concentration in molarity of the following solution: 23.1 grams of sodium hydroxide dissolved in enough water to make 1,000.0 milliliters of solution. To get concentration, we need to have moles and liters. We are given grams and milliliters. So we need to convert both of these amounts. For the grams of sodium hydroxide, we can find the molecular weight to be 40.0 AMU. That means 40.0 grams of sodium hydroxide equals 1 mole of it. We're given 23.1 grams. Multiplying it by the conversion, we get 0.578 moles of sodium hydroxide. We can put that value here. Now we can convert milliliters to liters. We have 1,000 milliliters. Multiplying it by our conversion relationship of 0.001 liters per 1 milliliter, we get 1.000 liters. To calculate molarity, we divide the number of moles by the number of liters and get 0.578 moles sodium hydroxide divided by 1.000 liters, which is 0.578 molar. That's our concentration of sodium hydroxide solution.